Let's take a look at how some of these concepts are applied in a few example problems. And the last example problem. The researchers in an Alzheimer experiment want to test the drug manufacturer's claim that fewer than 10% of patients who take its new drug for treating Alzheimer's disease will experience nausea. That is, they want to carry out a test of the null hypothesis, the proportion is equal to 10%. The alternative is that the proportion is less than 10%. So they want to build evidence to show that the alternative, they want to show evidence for the alternative that's less than 10%, where P is the true proportion of patients, like the ones in the study, who would experience nausea when taking new Alzheimer's drugs. The researchers determined that the power of the test to detect the proportion is equal to 8% using a random sample of 300 patients at a significance level of 5% is 0.29. Determine whether each of the following changes would increase or decrease the power of the test. Explain your answers. So they're running this test and they've determined that if it really is less than 10%, if P is less than 10% and it's actually equal to 8% using a sample size of 300, then the power is 0.29. The power would be the probability of them correctly rejecting the null. So if they use an alpha level of 0.01 instead of the alpha level of 0.05, will that increase or decrease the power of the test? This will decrease because using a smaller significance level makes it harder to reject the null when the alternative is true. A smaller significance level makes it harder to reject the null because the significance level is the top percentage that would cause you to reject. So if you reject the top 5% and then you decrease the alpha level, you're only rejecting the top 1%. So it's harder to get a value that is that far ahead of all the other values. Problem B, if the proportion is 0.06 instead of 0.08, so the difference between the null and the alternative has been increased, which means it will be easier to, it will increase because it'll be easier to detect a bigger difference between the null and the alternative parameter. Again, it'll be easier because the difference between the null and the alternative is increased. Think about it this way. If the true proportion is actually 6%, then you're a lot less likely to get a sample proportion that is close to 10. You're more likely to get one that is lower, closer to 0.06. Finally, if they use a sample size of 200 instead of a sample size of 300, that is going to decrease the power of the test because a smaller sample size gives less information about the true population proportion. So these are the three variables that influence power, and you need to know how they will influence the power of a test. The alpha level, the distance between the null and the alternative, and then the sample size.